able to gain or lose electrons.
Okay. Yes, anyone else would like to define the term? Okay, let me come to a very simple word. Uh, what do you understand by simply ionization? The word ionization. See, in this case, ionization is a formation of ion. From neutral atom is going into the ionic state. We can understand like this. And that process is called ionization. And during that process, uh, electron is removed. When electron is removed, positive ions will form. What would be the charge on the positive ion? That depend how many electrons you have removed. For example, if you have removed one electron, then the atom will form one positive charge. And for that, the starting atom, the starting element has to be in a gaseous state. The neutral atom has to be in a gaseous state. So when you start with the neutral atom in the gaseous state and when you remove electron, that process is called ionization. When you remove first electron, that is called first ionization. When you remove second electron, that is called second ionization. When you remove third, that is called third ionization. So first outer electron they are lost. Then the inner electron are lost. So we have to remove electron, the outermost electron we have to remove first, and then the inner electron. This is how it goes when we write electronic configuration. Just look the example of lithium. They have written the electronic configuration. You know lithium has a 3 atomic number and the configuration is a 2 1. So that one electron, that is outermost electron, so that is to be removed when we form a lithium ion. And you can see they have started with the lithium gaseous atom. So that is called first ionization. Now it is a very simple logic. The electron which you are removing, that is under the force of nucleus, because you know in an atom electrons are holded by the nucleus. Nucleus has a positive charge, so there is attraction of positive charge. So if you want to remove electron, you have to overcome that attraction. That means you have to give energy. So ionization is always endothermic. More or less, always energy is to be given to form positive ions. Endothermic, you understand, and all those processes which require energy, we have to give energy. That is called endothermic process. So that is called ionization, right? So have you all understood this? Any question?
No, sir, no question.
Okay. So you have also practiced like the way they have written for the lithium in the last class. I asked you to write about other element also. So you can note down question. Uh, I'm write down ionization equation first. The first is a first ionization of sodium. The second equation you will write for second ionization of magnesium. The first equation you will write for first
No,
ionization.
type it on the chat box or the screen, maybe.
Okay. So first equation you have to write. You have to write in a similar way like they have written for the lithium. First you are going to write for first ionization of sodium. And second equation you are writing for second ionization of magnesium. Are both questions clear to all of you?
Yes, sir.
Okay, go ahead.
Wait, I thought you said all the. Didn't you say if everything was clear?
Yes.
Yeah. Okay. I was just making sure.
Okay, are you done?
So the first ionization for sodium is 496.
So see how would be the equation? You will start with sodium in a neutral gaseous atom. You can write configuration here. What is the sodium configuration? 2, 8, 1. Sodium is 11. Can anyone tell me the configuration in terms of orbital for sodium? Who will say electronic configuration of sodium in terms of orbitals?
3s1.
Yes, that is outermost. 3s1 is outermost. So
Yeah, it's Ne3s1.
good. It is a neon 3s1. So in a whichever way you are comfortable, you can write the electronic configuration either in this pattern or you can write with the orbital also. Now, what is done in the process? An electron is removed. This is converted into positive ion. Removal of first electron. So the sodium ion would be 2,8. Or we can write neon. This is what the sodium ion. So this I have written the reaction for the first ionization of sodium. Similarly, can you write for second ionization of magnesium? Understand, you're writing for second ionization. You are not writing for first ionization.
So what's the difference first and second ionization configuration?
Second ionization is a removal of second electron. For example, if I remove second electron from the sodium ion, and if I form Na2 plus ion after removing second electron, which is a 2,7, obviously it requires more energy. After you remove first electron, then when you remove second, you need more energy. And in this case, much more energy. Why? Because it has a stable configuration. So this second equation which I have written, that is called second ionization of sodium. Is this clear?
So in the second ionization, you reduce the number of electrons.
We remove second electron. After first electron, when we remove second, that is called second ionization.
Okay,
So,
I understand.
so when you're removing outermost electron, you're removing first electron, that is called first ionization. And then after when you remove second, that is called second. And then when you if you continue to remove third, then that is called third ionization. But with every removal, remember the amount of energy required that will increase. And particularly it will increase very large when there is a stable configuration. So you understood what is a first ionization, what is second ionization, everybody?
Yes, sir.
Okay. So can you write second ionization for magnesium? You don't have to write for first ionization, you would write for the second ionization of magnesium. Who will say? Yes, who will say?
I'm confused on this.
Okay. Uh, what is a magnesium configuration? Magnesium we have to take in a gaseous state, obviously.
Wait, magnesium.
Huh.
Oh, I thought you said magnesium.
Mg, magnesium.
Yeah, I heard magnesium. That's what I heard.
Magnesium has a 12 atomic number.
Yeah. You want the atomic number or the electron configuration?
Electron configuration.
Ne3s2.
Yes, it is Ne3s2. And if I write in this way, then Let's say we want to write in this way, then how should I write?
No, son. It's not, the 2 shouldn't be written as like a power. It should be just written as a normal 2.
Which one?
3 as 2. The 2 should be not like a power. It should just be a normal 2.
It's not a power. It is a 2 only. That shows the number of electron. So do not
Yeah, hold
consider
on, sir. Let me, like, if you don't mind, can I note?
you meant to say that 3s2. Do you mean to say like this?
Yeah. Yeah, like that.
See why it is not written like this. Let me explain why it is written little bit up. Let me try to explain. See, you are writing the number of orbitals. After 3s, some other orbital will come, right?
Yes, sir.
So let's say if I'm writing in this way, 3s2, and then say let's say if I'm writing 3p, so that leads to confusion because someone may can read it 23. Are you getting my point?
Yeah, then why, like, I still don't understand, like, why is it written as like a PowerPoint instead of a normal 2?
So this is the reason the number of electron they are written like they are written above the orbital. It's not a power of the orbital, but the number it is written like little bit above. So you cannot read 23 together like this. Otherwise, see that leads to confusion. If I write 3s2, 3p6, and then let's say if I'm writing 3d, so for anyone to read it continuously, that leads confusion. Are you getting my point? What I'm saying?
Oh, okay. So it doesn't matter if you were to
Or
write like double, we have to write it like a PowerPoint. But if we're just writing it individually, like for example, magnesium 3 as 2, we can just keep the 2 as like a normal 2.
Yes, 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 yes.
So it doesn't matter how we put it.
Yes, it doesn't matter, but usually it is written like a little bit up. It is written the numerical value is written little bit up. Only the reason to distinguish the orbital.
Okay, it's just so you can read it easily. Yep.
So magnesium. Suppose if
sir,
I
I sent you the equation in the chat box.
good now. Magnesium, if I write in this way, the way I have written for the sodium, how should I write? If I am writing only number of electron, let's say we are not writing the orbital, then the magnesium we should write like this: 2, 8, and 2. Right? Is this clear to everybody?
Yes, sir.
These are the two ways.
Yes, sir.
These are the two different way to write electronic configuration. Now, when we are removing the first electron, that particular expression is called for the first ionization enthalpy, and the magnesium will acquire one positive charge. And the configuration will become neon 3s1. If I write in terms of orbital, if I write like this, will become 2, 8, and 1. So this particular equation which I have written, that is the first ionization. Now I have asked for the second. So let's say when you're writing for the second ionization, I'm writing over here. So we need to start with the magnesium ion. What is the configuration of magnesium ion? 281, that is the configuration of magnesium ion. Let's say if I want to write in terms of orbital, then what should I write? It is a neon and the 3s1. Then when we remove the electron, become Mg2 plus. What is Mg2 plus? Mg2 plus is a neon, or we can write 38 also, 28 also. This is called second ionization expression for the magnesium. So this is what I have asked in the question. This was the question. Okay. So you understood what was asked in the question. Have you all understood this?
Yes, sir.
Arman, 282, have you written for the magnesium? Have you written for the magnesium 282? Yes, yes.
Yes, sir. That was for magnesium.
Okay, okay. Okay, one last question for this. Right for first ionization of nitrogen. First ionization of nitrogen. Who will write? Who will say? First ionization for the nitrogen. Yes, who will say? What is the nitrogen configuration? Anyone? Nitrogen atomic number is 7.
Nitrogen. He
Okay,
2s2 2p3.
good. This is a nitrogen configuration. Or we can write 2 and 5. So when we are writing for the first ionization, we are removing the first electron, outermost electron, and the nitrogen will acquire one positive charge in the gaseous state and will lose one electron. This is the first ionization expression for the nitrogen. And whatever energy required for this, that is called first ionization energy of nitrogen. So what is the configuration of nitrogen plus ion He? If I write in this way, 2s2 2p2, or we can write 2 4. Is this clear? I have asked for nitrogen, not for sodium. Is this clear to everybody?
Yes, sir, it is
Yes,
clear.
sir.
Okay. As nobody answered this question, I'm giving one more. I hope this time all of you will do. Right, for the first ionization of aluminum.
Aluminium, sir?
Aluminum has a 13 atomic number.
Yeah, okay. Ne.
So I should start with the aluminum.
Okay, my turn.
Yes.
Sir, I have the answer.
1s2, 2s2, 2p6, 3s2, and 3px to the power 1.
That is wrong.
Okay, what do you want to correct, Dev?
It's Ne 3s2 3p1.
You both are right. The only difference is that
Not wrong. I just didn't say neon. That's
uh,
it.
she has expanded the neon configuration. So she said expanded form and you said with the neon. So you both are correct. Aluminum has a 13 atomic number. What the physical state I should write here for aluminum? We should start with which physical state? See, it is very important what you are writing here. Remember, do not write any other state other than the gaseous state. This I have said repeatedly. You have to start with the gaseous state. Understood?
Yes, sir.
Yes, sir.
And then the following that neon 3s2 and 3p1, or we can also write 2, 8 and 3. Both the ways are correct. Remove the one electron. So this will form one positive ion. Gaseous state over here. Neon. Then 3s2 it would be. Or we can write 2, 8 and 2. We have removed one electron. So we will write electron over here. And whatever energy required for this to remove this electron, that is called first ionization energy or first ionization enthalpy. Is this clear to everybody now?
Yes, sir.
Okay, okay. All right. So now we have to understand the pattern in the ionization enthalpy that I'm not starting today because we're left with the 3-4 minutes. You can take some question. We have discussed for which element? I have like we have discussed for sodium first ionization, magnesium, aluminum first ionization, fluorine first, sorry, nitrogen first ionization enthalpy. So we have written equation in term writing electronic configuration. Now, what is your homework? What you have to do? You have to draw the orbitals. You have to draw the shells. You have to draw the orbitals. Then you have to show the electrons with the dot, inner electron, outer electron, and then you have to remove the electron. This you will do for the first ionization of sodium. Note it down. This will do for the first ionization of sodium. And this you will do for first ionization of nitrogen. Noted.
Could you repeat the last time?
Uh, whatever the equations you have written for the first ionization of sodium and the first ionization of nitrogen equation already you have written. Now what you will do, you will draw the orbit. You will fill the electrons by putting dot, inner electrons, outer electron, and then you will remove. So, and for sodium ion also you will draw the orbital picture. So are you understanding electronic configuration? Now you have to draw in terms of orbit. Orbital diagram you have to draw. Is the question clear to all of you? This you are going to do for two element.
So,
Sodium.
sir,
Yes, sir, got it.
we have to make two diagrams, one of first ionization of nitrogen and one of first ionization of sodium.
Sodium, yes, yes, yes.
Only two diagrams.
Two diagrams.
Okay.
Okay, and this topic reading revision, or you can explore this topic from any source. So just complete the reading part also from whatever source you have, and this two diagram. Okay, clear to all of you?
Yes, sir.
Okay, okay, okay. So we will disconnect within a few seconds. Is anything you want to ask before that? You can ask.
No, sir. Can we leave?
Ah, yes.